This is assignment 4.5 Quantitative Data Analysis by Joey Webber. Quantitative data is research that is presented in the form of numerical data and quantities which can be put into categories, rank order, or measured in units of measurements. This type of data can be used to construct graphs and tables of raw data. The main ways of gathering data is for experiments, observations, and questionnaires. There are a variety of different benefits to using quantitative data analysis. Firstly, you can compare the results to normative data. This is data that has been complied against thousands of studies. This could be very beneficial because if you did a study of young British female gymnasts and were doing a study of the sit and reach test, you could compare their scores to the rest of the population and accumulate an average. Another benefit of using quantitative data analysis is that you can form a comparison between populations. For example, if you were doing a study on the flexibility of young British female gymnasts, then you could compare the results to the flexibility of middle-aged female gymnasts. Then compare the two results to see if there's a difference. Another benefit of quantitative data analysis is that it allows you to make predictions on performance. For example, if you have a graph of all the best gymnastic routines within the UK from the last 5 years, this will give you an idea of the level that you have to be at in order to be able to compete at the highest level. In addition, it will also enable you to be able to make predictions about who will be at the highest level of performance next year. As well as being able to make predictions on sport performance, it allows you to compare different kinds of sport performance, such as comparing the VO2 max of trampolinist and an 800-meter run. This allows you to create a comparison between the two data, which will allow you to increase the levels of reliability of the research. I'm going to be data organization. I'm going to be discussing the various ways in which you can organize data. By organizing your data, it allows you to increase the accuracy and reliability of your results. It will also allow you to see whether there are any similarities or differences between your data. There are 4 main types of data organization that I'm going to be discussing. These are range, rank order distribution, simple frequency distribution, and group frequency distribution. The range is the difference between the largest and the smallest number. It is the difference from the highest to the lowest value collected. To find the range, you need to subtract the lowest value from the highest value. For example, these are the scores of 5 gymnasts carrying out the flexibility test. 61 centimeters, 55 centimeters, 63 centimeters, 70 centimeters, and 68 centimeters. The range of these scores is 51 because 77 minus 55 is 15 centimeters. It is useful to find the range as it shows a good variation in results and allows you to see if there is a big difference in performance levels of a group of a person. Rank order distribution is where you place your data into an ordered list from the lowest to the highest in a single column. This method is only used when there is 20 or less units to deal with. For example, the Premier League is in a ranked order distribution as it displays the order of the team with the highest points down to the lowest. This is useful to see who is best and who is worst and how the difference is between them. Simple frequency distribution, the third type of data organization, has the potential to be used. It is similar to rank order distribution, and it would be used when you have a small range, n to 20. This type of data takes form of 2 column tables, with one of the columns representing the raw score and the other frequency of this score. The final type of organizing data that I'm going to be talking to you about is grouped frequency. This would be used when your data has a larger number in it and you are dealing with a large range. When deciding if your data consists of large enough numbers to use a group frequency, it is considered that you have data that has n to 20 and a range of above 21. Then you should use a group frequency. In addition, group frequency involves grouping these larger numbers into more manageable groups. For example, this is done in roughly 10 to 20. For example, when looking at data collected from Great British Gymnast javelin throws, we have a score of 500 plus with a range of 900. We need to group these, and this might be done by placing the score into groups of 100, for example 900 to 1000 or 1100 to 1200. This can be seen by looking at the graph that is on the screen right now. I'm now going to explain the various different ways that there are to present quantitative data. The second stage of quantitative data analysis is actually presenting the data that you have collected in a graph or a table. This stage of quantitative data analysis is essential because it is important to select the correct graph which conveys your data in the correct way. Furthermore, another factor to remember when choosing what type of graph you want is that the data you have might not fit into a certain graph, as each graph is used to represent different sets of the numerical data. The different types of data presentation that I'm going to be discussing are tables, scatter plot, line graph, bar chart, and histograms. All of these different types of graph can be used to represent different types of data. The first type of graph that I'm going to be examining is tables. Examining tables can help manipulate data in order to be able to make it into an amount which can be used in a manageable form. There are a number of different reasons behind why making the data into manageable chunks is the right thing to do. The first of these is the fact that you create units which can help categorize the data into groups, as these can be used to create the column which will form your graph and help you to portray your data. Another reason tables can be effective when trying to make your data manageable, and this is done by using a footnote at the bottom of the table. A footnote is a note at the bottom of the page that provides information, can also help to show reference that could potentially be used. Footnotes also provide important information about the table, makes it easier to read and understand. An example of a table using the Great British Gymnastics Squad is shown on the screen, which records a group of athletes' flying, sprint and sit and reach scores. The next type of graph that can be used to portray quantitative data is a scatter graph. Scatter graphs have an X and Y axis which have values that you can use to plot each point. Scatter graphs are a natural way to visually display the relationship between two quantitative variables. A series of plots represents the position of the observations from the dataset. Usually scatter plots have a single line running through them. The line of the scatter plot represents the trend or the relationship between the two variables. Scatter graphs are best used when looking to compare large numbers of data because it will clearly show the relationship of the variables and will save you having to go through the long list of data in order to find your conclusion. For example, in figure 1 it shows the correlation between the upper arm girth and chest throw. The graph clearly states how there is a positive correlation between the upper arm girth and the chest throw. The third type of data presentation that can be used is a line graph. Line graphs are usually used to show the dependent data and to display change over time as a series of points connected by straight lines. The line graph therefore helps to determine the relationship between the two sets of values. With one data set being dependent on the other, line graphs are used to track change over a short period of time. Line graphs are used in that they show the data variables and trends very clearly and can help make predictions about the results of data not yet recorded. For example, in figure 2 it shows the skin fold calipers of the bicep and triceps. The graph shows us the difference between the tricep and bicep skin fold calipers. Another type of graph that can be used to show the findings from the collection of quantitative data is a bar chart. Bar charts are often primarily used for displaying the qualities of qualitative or the quantities of qualitative or categorical data, for example, age groups or religious affiliations. However, they can also be used for quantitative data if the number of unique scores in the dataset is not large. A bar chart plots the number of times a particular value or category occurs in the dataset, with the length of the bar representing the number of observations that the score or in the category, and the other axis represents the different units. Bar charts can be either displayed horizontally or vertically. However, I think they're better displayed horizontally because it just looks a bit clearer. The final type of data presentation that can be used to show quantitative data is a histogram. These are similar to bar charts as they both look at the frequency of the data. However, histograms are not continuous data, meaning that the data has no gaps in it, unlike a bar chart which has gaps and are not continuous. Next, I'm going to be talking to you about the normal distribution curve. The normal distribution curve, or otherwise known as the bell-shaped curve, refers to data being centered around the mean and is the average of the dataset. The curve of the data has a single peak which represents the mean, mode and median of the dataset. This is known as the central tendency. The central tendency is a single value that attempts to describe the data that represents the center of the distribution. They describe the average of the distribution of the dataset. There should be an equal value either side of the peak, which subsequently represents the median of the dataset. As histograms measure the frequency, for example, the tallest and the highest value of the data, they represent the mode of the data. Therefore, this is now the mean and the average of the dataset that you have collected. The data surrounds the mean and is symmetrical and uniform half of the data, and the uniform half of the data will lie to the left of the mean, and therefore the lower half to the right of the mean. The lowest and the highest values surround the peak and the distribution curve. These have the lowest frequency, with the peak of the data being the most common value. The two tails of the distribution curve will never touch the x-axis. Normal distribution curve can be a different range of sizes and shapes. They can be flatter curve, steeper curve, and as long as it is symmetrically centered around the data, it is still normally distributed. The standard deviation refers to how dispersed and spread the values are from the mean center of distribution graph. If the scatter of the data is close to the mean, this means that it has a low standard deviation and variability of data, whereas if the data is spread out from the mean, it demonstrates a high level of standard deviation and variability. The empirical rule can be used in order to work out what percentage of values are grouped around the mean and the normal distribution curve within a specific number of standard deviation. One standard deviation away from the mean will include 68% of the data, therefore 34% below and 34% above the mean, so it is equally divided. The largest amount of data will fall into this percentage. Two standard deviations away from the mean will consider for roughly 95% of the scores. Therefore, 47.5 below the mean and 47.5 is counted above the mean. Three standard deviations away from the mean consider 99% of the data. Therefore, 47.5% below the mean and 47.5% is accounted above, and the remaining values are either extremely high values that are away from the mean. The image on the screen shows what a normal distribution curve would look like. This image demonstrates that there can be variation in the dataset. This includes their height, width, and their meanings. Both of the curves are defined as a normal distribution curve, but just vary in height, width, and meaning. Both the men's and women's means could be of the same, but when you use the distribution and the standard deviation has differentiated them from one and another. However, the shape of the curve will not always be symmetrical. Sometimes the curve of the graph will be asymmetrical, meaning the data is not distributed normally. The shape of the curve can either be positive or negative, depending on the direction of the curve. A skew refers to a sudden change or direction of position. In this scenario, the skew relates to the more numerical data being on one side of the mean in comparison to the other. A positively skewed graph has a tail that points towards the higher end of the scale, whereas a negatively skewed graph has a tail that points to the left.